The screen is visible?
Yes, sir. Yes, sir.
It started recording.
It is visible and recorded also started. Sir will finish. After that, you can ask your question. Okay. First, I will finish the things, and after the each video, we will give you time to ask questions. At that time, you can ask. Yes, sir. You show your full screen mode, then start, sir.
Yeah. Okay, so everybody can see the slide?
Yes, sir.
Yes.
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
Yeah, good afternoon all. Today, as you know, as per the schedule, we are going to discuss about the practical experimentation on the experiment number 5 in EEC01 lab course, that is open circuit and short circuit test of single phase transformer. So in the earlier class, we have already understood what is a transformer. It is an electrical machine. So it is a very high efficient machine and it can transfer the electrical power from one circuit to the other circuit with the variation in voltage and current, keeping the frequency constant. So now as we are going to do the open circuit and short circuit. So just we will think about that how the transformer can be made in open circuit condition and how it can be called or it can be seen as short circuit condition. So for any circuit, as shown by this slide, if the circuit is closed, then circuit will send some current. If this part is closed, circuit will send some current and the load will get some electrical power from the source. And whenever there will be some discontinuity, if that part is not there, then the circuit will be called as open circuit because this circuit is not closed. So it is open. So that's why it is called as open circuit. And in case of short circuit, if the load points are connected by a firm wire for which the resistance is considered to be almost zero, we will call it as short circuit. So voltage of this point and that point will be same because these 2 points are nothing but the single point, one unique point, and that point will not be able to send any current because voltage is same. So there will be no voltage difference between the load points. So there will be no current and the lamp will be outside the circuit, means it will not get any electrical power. So this condition is called short circuit condition. So this is open circuit condition. Now for any transformer, if we have the drawing like this, sorry. So how the open circuit and short circuit can be understood here? First of all, transformer will have two windings. Transformer will have two windings, electromagnetically coupled. So there will be iron core and there will be the conductors. That conductors are placed as a solenoid or winding turns. So there will be several number of turns in both the windings so that the electromagnetic field will be generated. Magnetic flux will be linking with each other and we will be able to transfer the power from one circuit to the other circuit. So this is a circuit where we will give electrical power. So that's why it is called primary. And then from where we will get the power as an output. So we will call it secondary. OK. So we will give electrical power. We will connect it with 220 volt supply or anything else depending on the rating of the transformer. And we will be getting sometimes more than 220 volt or less than 220 volt. And accordingly, we will be able to increase the voltage or decrease the voltage. So now here, if one source is there, our say 3-pin plug point where there will be 3 points. So this is live point, this is neutral point, and this is earth point. So like that, there will be 3 pin plugs and we will be able to take the power from here. So whenever these two will be coming here, so please remember that 3 pin will be there, but one will be earth point. So main current will flow from the live through the load to the neutral. So there will be 2 points here. So now if we connect the transformer here, then this winding will be taking power. So this will be working as the load. Transformer will be working as the load. Now whenever this power will be transferred through electromagnetic induction, so this section or secondary coil will be working as the source. So we can connect the lamps here. Okay. So this is the actual phenomena what happens in case of transformer whenever it is connected to any power supply. So this is wall plug point. This one is wall plug point, 220 volt supply is there. That power will be given to the transformer either directly or through any other thermostat or any other thing. So we will be giving a voltage and that voltage will induce some other voltage here, and that winding, when it has some voltage, it will be able to deliver some power to some external circuit or some lamps if it is connected. So the short circuiting of transformer or open circuiting of transformer will be understood by this winding, means this part, secondary part. So first of all, I will draw again transformer and I will show you if these 2 points are kept open, then this condition will be called as transformer is working as a open circuit condition. But this 220 volt will be there. So this is connected. Okay. So there will be the wall plug point supply will be there. It is connected. Primary is connected, but secondary is not connected with any load. So this condition is nothing but the open circuit condition. Similarly, whenever the transformer primary will be connected, but the secondary will be connected in different way. Means if it is shorted or connected by a single wire, then it is called the short circuited condition of transformer. And we can connect this with ammeter also, because ammeter has very less internal resistance. So it will be considered to be zero resistance offering to this circuit. So definitely this is also short circuit condition. Similarly, in open circuit condition, if we put on voltmeter, as the voltmeter internal resistance is very high, so we will also consider that this resistance is ideally infinity. So it will be also considered that this is open circuit condition. So in case of our laboratory experimentation, what we are going to explain, if we want to keep the open circuit condition, we can make it open physically, or you can connect through a voltmeter. If you want to make the transformer in short circuit condition, we can connect by anywhere, or we can connect through any ammeter. But before connecting the ammeter and before connecting the voltmeter, we need to know two things. One is what is open circuit voltage here. Open circuit voltage means what voltage is available. This may be say 100, this may be 200, this may be 55. So that is depending on the transformer, whatever we are going to use. So on the nameplate, all the information will be given. What will be the open circuit condition voltage, and this voltage should be less than or equal the voltage range of voltmeter. Any voltmeter, if it is manufactured, so it will have its tolerance or it tolerating capability, means how much voltage it can tolerate for maximum, means its rated voltage for which it is scaled. If it is say 0 to 200 volt written, that means any voltage between 0 and 200 it can measure. 250 cannot be measured by this voltmeter. So that we have to remember. If it is 100 volt, so we can use 0 to 150, but we cannot use 0 to 80. That voltage or that type of voltmeter cannot be used. Similarly, in case of short circuit condition, if we know that 20 ampere is flowing through this circuit, because short circuit current means there will be large current. So if it is flowing with that amount of current, so for connecting, before connecting ammeter also, we should know that whether the ammeter is for 0 to 20 or at least 20. It may be 0 to 30 also, 0 to 50 also, that is possible. But also one thing we should remember, for measuring one certain quantity of current or voltage, range should be nearby. Means if we are measuring for 20 ampere, we should not connect 0 to 200 ampere ammeter, because that 20 will be very less and the scale deflection will be almost nearer to the 0. So that calculation will be manually will be difficult. So for if we are getting say 1 ampere somewhere, we cannot connect it to the 20 ampere range emitter. So it will be giving some say wrong reading, or we will be taking some wrong deflection reading. So if it is 1.5, it is better to go for 3 ampere, 0 to 3 ampere, or 0 to 5 ampere. Like that we can go for that. So this is about very basics about the short circuit condition and open circuit condition of the transformer. And as we have already discussed, that open circuit test is conducted to estimate the iron loss, and short circuit test is conducted to estimate the copper loss. So now we will play the video, but before playing the video, we will show you the panel boards where we have conducted the open circuit and short circuit test. So there is another table also where we can conduct the same experimentation. So in the laboratory of our department, 2 tables are there, and we can conduct the transformer experiment for 2 batches. So that's why we conducted say open circuit in one bench and short circuit test in other bench for saving some time. And we can see that this is the panel board. What is the panel board? The panel board is one kind of just simple board which is used for installing lightweight instruments, as well as for showing the circuit connection, and also for helping us to connect the instrument very nicely. So here we can see that transformer is drawn here. So this is drawn. That means here this is the actual physical transformer, means actual transformer. So there are several windings. So this is a primary winding, and this side is a secondary side. So these 2 points, that is red and black, we can see from here, not very clearly. So it is connected these 2 points, okay, primary side, and other points are also connected to this. How it is connected? You can see some wires. So these wires are going down, and it is taken to the back side, and it is connected. Why it is connected backside? Because so that there will be no say any disturbance will be there, or if all the wires are already there in the front side, so it will be very difficult to connect all other components or instrument, because there are several components. You can see, say voltmeter is there, ammeter is there, wattmeter is there. So those instruments are also required to be connected for conducting the experiment. So before we connect, if already the front panel is already clumsy, and if it is not very cleaned, then it will be difficult. So few wires are connected which are not required to remove. Already connection points are required to be made. So those are already made from the back side. So we can see what is there in the back side. We can see these type of wires are connected. So we saw that these these wires are coming from the transformer, and we can match, or we can imagine our earlier picture that these 4 points are there. We can whatever you can see here. So these 2 points and these 2 points are actually shown this backside. Another, these 2 points are, what is this? We can see here. We can see that these 2 points are nothing but these 2 points. These are the panel meter, digital voltmeter. Some voltmeter are already installed in this board, and we can use those things for measuring the voltage. And this is our plug point, which is already installed in the wall, and this is giving 220 volt supply, and that 220 volt supply can be utilized for conducting the experimentation related to electrical technology lab. So after that, I have already explained these things. Say nameplate, how the nameplate is to be read, and how the rated values are to be calculated from the nameplate, like say 1 kVA transformer, 55 volt by 220 volt, or 220 volt by 55 volts. So all these things are already explained. So now we will go to the next part of the experimentation demonstration. So probably Vore sir will play the video. So Vore, you can
Yes,
play those
yes,
videos.
yes, yes.
And after that, we
You
will
will
have
stop
plenty.
sharing.
Yeah. So after that, we will have plenty of time for discussing about any doubts if you have. So we can do that. But before that, I will just unshare my screen. Give some time. Okay.
Yes, yes. It
Yeah.
is
Done. Yeah.
done. So, is my screen is visible, sir?
Yeah.
Okay, fine. So all of you see carefully these videos. After that we will do discussion. If you have some doubt, then we will see this. Okay. So first you see video. After that we will discuss.
This is our electrical technology laboratory. List of experiments. Okay, here you can see experimental table.
Is it audible?
Check this network theorem 1.
Yes, sir. Voice is slow,
Yes,
sir.
sir.
Network theorem 2.
Okay.
Assis, you increase the volume if possible.
So from my side it is 100%.
Okay.
This is
It is increased 100%.
fluorescent lamp.
So students, wherever you will need to repeat the video, but just let us know. We will stop it and we will rewind. Okay. Or you can ask
This experimental table for three-phase
in
star
between.
delta
We will explain.
connected load. Here, this one is for single-phase transformer experiment, open circuit short circuit test. This table is here. The table. Same that for open circuit and short circuit test verification. Here, the characteristic of different kind of incandescent lamp. Here you can see this one. This is the experimental table for that. Here, this is another setup for that. Different incandescent lamp are connected here. This is a study of series and parallel circuit. Series and parallel RLC circuit it is. So this is experimental for that. Another one. This is another setup for same experiment. Study of series and parallel RLC circuit. So this is overview. Okay, thank you. Today we are performing
This is open circuit test now.
Open circuit and short circuit test on single phase transformer. So here we have to see this is a single phase transformer. This is the primary and secondary. Okay, so this is primary and secondary. So primary and secondary we can change as per the our requirement of the system. We are performing open circuit or short circuit test. Okay, so this is basically the single phase transformer actually. Okay, from here you can check, and this side is 54 volt side, this one here. Okay, this is basically 220 volt side. This connections go this side 220 volt side. Okay, so first we have to see the connection diagram of open circuit test. You check this one. So here apparatus required are one single phase variac, one emitter, two voltmeters, one wattmeter, and wattmeter should be low power factor wattmeter. Okay, so because this is no load and open circuit test, in the secondary we will not connect any load at that, so very low power factor is optional here. So LPF power factor wattmeter we will use here. Okay, and we will perform here. You see the open circuit test on this side, the 220 volt. It means open circuit voltage always perform on the high voltage side. So here high voltage side is 220 volt. Low voltage side we have to connect all the meters, measurement meters. This is basically 54 volt side, and your input voltage is what rated value of input voltage here. If we perform the open circuit test here, so input voltage rated voltage will be 55 volt. Then you will not supply more than the 55 volt. Okay, so you have to observe. You have already seen this connection diagram. Okay, so here according to the connection diagram we have to connect the circuit. Here the range of the different meters, here you can check. The supply is 220 volt or 230 volt. Okay, the emitter, this is 0 to 1 ampere. LPF wattmeter we have. Okay, this is LPF wattmeter. Okay, specification we have already or we will already see that we will see later. Okay, now this voltmeter whatever will connect on the primary or that 55 volt side, this is 0 to 150 volt, and secondary side this is basically 0 to 300 volt, because the rated voltage is secondary side is 220 volt. Okay, that's right. Okay, According to this connection diagram, we will connect. Okay, we will start the connections. So this is basically supply. Here we have connected, this is single phase variac. Here you can see this single phase variac, this 2 terminal of single phase variac, 0 to 300 volt, because the rated voltage is secondary side is 220 volt. Okay, that's right. Okay, according to this connection diagram, we will connect. Okay, we will start the connections. So this is basically supply. Here we have connected, this is single phase variac. Here you can see this single phase variac, this 2 terminal of single phase variac, it is here. So after that single phase variac you have seen in the connection diagram, the emitter is here. Okay, so after the single phase variac, here you can see parallelly single phase variac, after the emitter, and it should be 0 to 1 ampere range. After that M terminal of the wattmeter, after M to C short. Okay, M to C short. After that M in means it as C for common, that L, it means after that load will connect. Okay, so L terminal, L to the primary winding or 55 volt side you have to connect. Okay, after that V basically again we connected to the negative of the single phase variac here. Okay, and again the same terminal will go to the another terminal of the primary winding 50 volt side. Okay, and voltmeter with range of 0 to 150 you have to connect to the 55 volt side, primary side. You will connect this one. After that secondary side, high voltage side will be open. This is basically what 220 volt side, it should be kept open for the open circuit test. Okay, here we will connect to measure the open circuit voltage. It will be, we have to connect voltmeter of the 0 to 300 volt. Okay, within this range we have to connect. Okay, we will see the connection diagram exactly how we will do. So this is single phase variac. After that, this is, we have kept one terminal as positive. After that, we have connected this emitter. This is the emitter we have connected. This is common. After that, this is 1 ampere. 1 ampere range we have connected here. You can see this one. This is the 1 ampere. 2 ampere. This is 1 ampere. We have connected at 1 ampere. Okay. After the 1 ampere, this terminal goes to where it will go. You see at wattmeter to measure the input power. This measuring this input current. This will wattmeter will measure the input power. Okay. So here at M terminal, here you can check. This is M. Now M to C should be shorted. Here we have used this wire to short the M to C. After that, from L terminal, this is L. We have connected the, this color is L. This is 55 or LV side binding. Okay, 55 volt side binding. Okay, we have connected. And the negative terminal, this is positive one. Then negative terminal of this low voltage side is again connected to the negative of the single phase variac. Here you can see this. Okay. Now one more connections for the voltage of VV terminal of the wattmeter. Here you can check this one. The V is connected to the negative of the voltage as you have seen in the connection diagram. It is connected here, as you can see this way. Okay. So this primary connection you have done properly. One more connection to measure the voltage across the primary side voltage. Okay, so we have to connect one voltmeter. This is the voltmeter range will be, because we are measuring the primary side 55 volt. So voltmeter range here not 155 it is available. So minimum range available is 150. In 150 we will connect. You see this 2 terminal. We have connected this basically this side here 55 volt, another one at, we have to see, just we will connect at 55 volt side this one, and another one that to measure the open circuit volt at high voltage side. So I am connecting. Okay, this one terminal I have connected here. Okay, this one, and 150. This is basically 150 volt side. This is 150 volt side. I am connecting here in the negative terminal of 55 volt. here I have connected. This connection was not connected earlier, that's why I'm doing here only. Okay, this is basically measuring the input voltage on the primary or low voltage side, and this is already connected. As you can see, this is connected to high voltage side, to 220 volt side, to measure the open circuit voltage. Here it is connected, and this is again at which range we have connect. So we have to connect this 0 to 300, it means common, and this is 300. So basically the common is connected to the positive. This you can see common is connected to the positive. Here it is connected, and negative to that you can check that it is connected to the this wire gone here to 300. This will give you the open circuit voltage on secondary side. Now very important thing here for wattmeter. Okay, so wattmeter here you are seeing the okay different wattage, but here the concept of multiplying factor is there. So we have to see the nameplate specifications. Here you see this is basically nameplate for wattmeter, and here what connection we have made, we have to see here. If the B1 B2 is connected, here you see one strip is connected between the B1 and B2, it means the connection, internal connection is B1 B2. So this will decide the current rating. Okay, if E1 E2 is connected, then other range is there. If V1 V2 is connected, then other range is there. Okay, and voltage also you see that two voltage there, that's 250 and 125. Okay, so based on that we have to decide the multiplying factor. So we have to see the nameplate. You see here it is written multiplying factor. I think it is more clear now. The current we are operating, it means B1 B2, from where we will get that connection. Here you see B1 B2 is connected, just I shown you this B1 B2 is connected here through the strip. So B1 B2 is connected, and current range is how much? 1 ampere, and we have connected at which terminal? 125. So you see 125 for multiplying factor here. If 125 it is there and 1 ampere is there, multiplying factor is how much? 1. So whatever it will measure, that will be your true reading. Okay, if multiplying factor is 2, so to find the actual reading, basically whatever wattmeter give, we have to multiply by its multiplying factor. If you are operating 2 ampere, okay, you have connected E to B1, B to E1 like that, then in case what will happen, you are operating at 125 and 2. So here basically your multiplying factor will be 2. Then whatever wattmeter reading will come with 2, and you have to always multiply by 2 or whatever the multiplying factor. Okay, so this is basically, so here is a very easy one. So here multiplying factor is 1. So not need to multiply anything. Always whatever reading will come, you have to take that. So you have to, we have to take now reading. You will note down the reading. Okay, and this basically this is your observation table for open circuit test. As you can see, this OC test. Okay, for this.
Sir, one doubt is there.
Switch on the supply. Before that, we have to ensure that our variax should be at 0 position. As you can see, it is this node at 0 position. Okay, now we can switch on the supply from here. We'll switch on the
Ashish, are you there?
here, light is flown.
Yes.
Somebody asked some doubt. You please pause and
Just wait. Okay.
yeah.
Yes, what happened?
Yes, sir. Sir, my doubt was that in the wattmeter, sir, we are connecting to 125 volt pin. Sir, but
Yeah.
the primary side is
Only 55. That's right.
acha. Okay, sir, fine.
That you, I have already cleared that open circuit side with 220 volts, and primary side will be, you are connecting all the meters. It means input side 55. That's why we are connecting possible whatever low voltage in the wattmeter on that side. Okay.
Okay, sir. Thank you, sir.
Okay.
Okay. Now we will start. This open circuit test is performed on the rated voltage. We will give rated voltage how much? 55. Okay, because primary is 55 now. High voltage, low voltage primary, and high voltage secondary. So from here, now all of you see here towards the meter, it will give, this is our primary meters, we have to see this one. We should not more than, now we are increasing from here, see this simultaneously we are increasing slowly, slowly, slowly. Now check the voltage also here, check the voltage. We have connected at 150 side. It means here you see the two reading is there. Two indication of this 155. So 150 is, it is lower side. The voltage also here.
It is audible, TKV sir. Okay.
Yes, yes.
It is audible, no? Okay.
Check the voltage. We have connected at 150 side. It means here you see the two reading is there. Two indication of this 155. So 150 is, it is lower side. Okay, if it is connected at 300, then you have to see upper scale. Now lower scale you have to see here 150 range at lower side. Okay, so now it is increasing, increasing, increasing. I am just increasing the voltage. Now you see this indication is increasing. Okay, now you see indication this. Now it is 50. It is reached to 50. Okay, we have to go 55. It means I have to increase little bit. 5 value. Now it is 55. You see this is primary voltage. It is 55 now. Okay. Now see the secondary voltage here. Secondary voltage, open circuit voltage, how much? This is approximately 220. Approximately, not exactly, or more than that. 220 like that. Okay. Whatever voltage will come, you have to take only one reading. What is the primary current here? You see here this primary current. This is the primary current value. What is the voltage? Input voltage. What is the input power? You see from here to here. You see this one. It is basically now 16. This is 18. Between that, this is 17. Approximately 17. Not. I will take approximate value. Approx 17. Okay. So here I will note down all the readings. So voltage, wattmeter reading for the open circuit. This is W0. For open circuit, this is 17 multiplied by 1. This is multiplying factor. This is, we have already told you, multiplying factor. Here multiplying factor equal to 1. How to calculate? From the wattmeter. So 17 into 1. Here secondary voltage, how much? We have seen 222. What 220 approx? 220. Approx 220. Here we have to carefully see this voltage reading. It is 220 and this is 240, approx 230, more than 230. So whatever it will come, you just note down here 230. I am just taking 230 volt, second volt. What is no load current? No load current we have to see, because we have connected again in the lower, it means 0 to 1 ampere, 0 to 1 ampere range. So we will see the lower scale value. Okay, so 0 to 1 ampere is lower scale one. So we have to take. We have to see, this is basically 230 volt. More than that, approx 230 volt we have to note here, 230 volt. Okay, no load current we have to check here. We have already noted down no load voltage. This is wattage also we have noted down. Okay, here wattage also we have noted down. Approx 17 it is there. Okay, so input voltage we have noted down, and the second, it means primary voltage, low voltage side voltage, and high voltage side voltage we have noted down all the things. Okay, so after that we have to calculate the parameters. Okay, open circuit test parameter. So open circuit test parameter, based on these formulas we have to calculate. Okay, first we have to calculate the power factor, no load power factor. So cos phi naught equal to W0 upon V1 into I naught. This parameter we have. Okay, this is separate formula. From here, IW, it means working component. It is this IW equal to I naught cos phi naught. Magnetizing component, it is basically I naught into sin phi naught. Just put the value, you will get this value. After that, you have, it is already discussed in the theory that if it is not discussed, later on it will be discussed. So for the open circuit test, what is basically your equivalent circuit diagram is this. It means IW here, this is IM here, Because in the secondary side you will not connect anything. So final equivalent circuit for the open circuit is this one here. V1 is supply voltage is there. So this is approximate equivalent circuit for the open circuit test. Okay, this is basically I. This is I1. I1 have, or the, we can say I0. No load current is here. Okay, so that's about the open circuit test. After finding this, we have to also calculate the R0 value and X0 value by putting this value. Now
In this
you
particular
have
case,
all known quantities.
in this particular case, V1 equals to 55 volt.
Yes. We have noted down the reading. No? So V1 equal to 55 and V2 equal to 230.
तो सर आपने
Yes.
बोला था कि मतलब 0 to 150 वोल्ट होगा
0 to
150
0 to 150. That you are using that wattmeter. You see what that voltmeter you are using, and wattmeter that we are measuring that primary voltage is 55. Okay, that as per the transformer rating. Okay, so it is, due to the range problem, voltmeter is not less than 150. That's why we have used 150. You can see here. Okay, I can show you where when we have connected 150 in the primary side. Just I show you this thing. You see, this is 55 volt side. This is 220 volt side. So here we have connected 0 to 150. Transformer rating voltage will not change. That voltmeter, whatever you can connect, this is fine. You can measure in 300, but scale is not proper. Okay, you can see here it is we have connected.
And dear students, the thing 0 to
You see, this is connected 300 for the secondary 0 to 300 volt, but rated voltage is only 230. Okay, in the secondary side 220 or 230. And you see here we have connected in the primary side. You see, I will just show you this thing. Here we have connected 0 to 150 range. At this point you can see. You see, this is 150 connected. It means we have connected voltmeter with range of 0 to 150, which can measure 0 to 150, 155 volt, whether 0 to 55 volt very easily. Understood? These things, transform rating will not change. And you have to note the V1 value as per the whatever the voltmeter V1 will give, which is connected primary side. It means 55 volt side. Okay. It is approximately 50-50. That we have increased up to the rated voltage, 0 to 55 volt we have set in the primary. So the V1 will be 55 volt. V2 equal to, I have already told you when we have recorded, V2 equal to 230 volt. Approximately 230 or like that. So just we have noted down 230. Okay.
Answer the calculation, please explain afterwards. The calculation which you did in the last, the equivalent circuit part, which you have done.
That manual is shared with you, na? Manual is shared with you. Manual.
No, sir.
Yes, sir. Yes.
How you can say no? Manual is shared in very early classes before starting the laboratory. Okay. Also the instructions.
MS Team it is.
Yeah, it is available in MS Team in file section. You can go. You can download manual. I show you here only.
I have sent the manuals in the WhatsApp groups also.
WhatsApp group also they have shared. You see the instructions manual. Here it is. It is here. This is a proof for that we have uploaded. Okay, today ago also, and I will show you if that mail also it is available, and Rajiv sir already shared this manuals also. I will show you these things. How you can say it is not shared? Who is saying?
sir.
I was asking, sir, if it.
So manual is there. It means you have not gone through the anything. It means you have not gone through the manual. This you see, this manual is shared very earlier. Okay, you have not gone through the manual. You have not seen even circuit, and you are coming to performing the laboratory. And you see, you have not seen even this videos we have already shared earlier. Okay, you can see it is fine, but
Videos
now
I have seen, sir. Videos.
just let me finish. You see this in this manual, everything is given the parameters. Is it okay for OC test in short circuit? What we have noted down here for that different equipment, that it means apparatus, whatever we have told you in the experiment recording also it is there, that serial number 1, this different equipment, okay, apparatus required. So one voltmeter, that rating is 0 to 150, which is connected primary side. Quantity 1, okay. Serial number 2, 1. Another voltmeter, that rating is 0 to 300, like that, and quantity 1. Again, equipment number 3, wattmeter, that rating you have to specify how much rating you have used, that 0 to 125 volt, 1 ampere, okay, that, and quantity 1. And that is basically LPF wattmeter, low power factor wattmeter. It is also written here in your circuit, that LPF wattmeter we have used here, okay. This you can see, okay. So all apparatus you have to note down here. After that, whatever I told you, that V1 equal to that one reading, it is performed at a rated voltage. So one reading is sufficient here. So V1 equal to 55, and V2 is how much? V2 equal to 230. Here this is not WSC. This is we have to correct. Or you correct. I have already corrected in video. This is W0 for open circuit test. This is W0. This will give you basically in open circuit test. This will give you the open circuit losses. What is that? RL losses. This is fixed losses. Okay. So this you will get here W0 for open circuit test. So you know here W0, V1, I naught is what? No load current. You know this is 0.24. Okay. So you know, so you can calculate the cos phi naught. You can calculate or not. I'm saying about this manual. Okay. Calculating of parameter. Okay. Yes, this one. So W0, this is how much? 17 divided by V1, how much? And that divided by multiplied by that V2 divided by V1 into I naught. This one. Okay, W0 divided by V1 into I naught. After that, after finding this cos phi naught, you will calculate again IW equal to I naught cos phi naught. Okay, you know I naught value, you know cos phi naught value. Just multiply this, you will get IW. This working component. Okay, then IM also you will get after calculating the this formula using
Cos
this one,
phi.
I naught into sin phi naught. Sin phi naught. How you will calculate sin phi naught? All of you know the sin phi equal to what? Under root of 1 minus cos square phi naught.
Minus cos.
Yes, yes. You use this trigonometric relation, then you will get sin phi naught. Okay, based on that, now you know everything. V1, I naught, cos phi naught, I naught, sin naught, everything. So you can calculate R naught. After that, you can calculate X naught also. Please, you can calculate within that 2-3 minutes. If you can give me answer for that, that it is okay. Already you have readings. If you know that you have noted down these readings at last, that is fine. The 230 volt, these readings, if you have noted down, you can calculate within 2 minutes. Okay. If you want, then I can show you the readings. Okay. After that, we will continue. Is any problem here to calculating this parameter? Now you tell.
No, sir. Any problem is not there.
No,
But
sir.
I don't understand why are you dividing it in IW and IM and that part, equivalent circuit part.
Okay, okay. IW and IM. That when already it is cleared that when sir covered that theory, and it will be more clear. Have you that covered in your theory classes this transform or not?
No, sir. The transfer.
Okay, so
No,
okay,
sir.
fine. Okay, so you for now you understood that main component here, this I is coming. It means I naught is coming from this side. Okay, this. So what here? Two component is there for this I naught. One is responsible for magnetizing the transformer. Another one is for actual supplying the losses. That is called the working component. Okay, which which is represented by IW. Okay, and another component responsible to for the transformer action. Okay, through which the mutual induction is possible. So that is basically represented by the IM, magnetizing component. Okay, so I naught basically supplied through the two component, or we can say I naught is basically variation of two component, one working component as well as magnetizing component. Okay, as we have represented, and you will see this theory about the working component, magnetizing component when we tell you that transformer. Respective teacher tell you theory about the transformer. Okay.
The parameters. Okay, open circuit test
Sir,
parameter.
please,
Yes, yes, yes.
pressure coil and current coil. I'm a little bit confused in both of them. Which is pressure coil and which is current coil?
Okay, if you are confused, tell me one thing. When voltmeter is connected in parallel or a series?
I think CV is pressure coil and ML is current coil.
No,
Am I right?
first, no. I am just giving you very right way for how you can measure the voltage, and when you want to connect particular voltmeter, then you will connect in parallel or series.
Parallel. Sir.
Parallel. And current in series. Okay.
Series.
Now you see whatever series you can see from after this M point towards the loads. You see this is ML. ML. So ML basically the current coil. And
Okay, sir.
with that parallel to the voltmeter, you can see this is basically MCV. This is basically the CV is the what potential coil or voltage.
Potential.
Okay. It is very easy concept to remember about the coil. Okay, if you forget what is that, so here it is represented parallelly that one voltmeter is connected input side, and you see one V terminal is also there. It means CV is the potential coil. Okay. Yes.
Thank you.
Okay. TKV sir, you can continue after that, or should I play? If you want to continue any additional
Primary
thing.
voltage is 230 na?
What?
Primary voltage should be 230 volt na?
You
No,
tell
it is secondary.
after
Secondary
playing
Otherwise,
after
sir,
playing all the
sir,
videos.
secondary.
Yes.
So in videos, secondary voltage is 230 volt,
Yes,
and
yes.
primary voltage is 55 volt.
Yes.
But
Yes.
if we calculate open circuit test, cos phi is 1.2, 1.28. If we put W naught equal to 17, V1 is equal to 55, and I naught equal to 0.24, then
Yes.
cos phi equal to 1.28.
1 point.
It's more than 1.
It is not possible. Okay, so
It is
later
not
on
possible.
I will check.
That's why.
Yes. Okay. Okay. I will check reading. Maybe some problem while taking the readings. Okay. I have to check that one. Okay.
And sir, we have to write the whole experiments as
Yes.
it is written in our manuals.
Yes. 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 Rajesh sir also given instructions. Okay. Have you seen instructions?
No, sir, till
Yes, sir.
now.
Yes.
Yes,
It is
we are
given.
little
It is
bit
given.
confused.
Yes.
That's why.
What is confusion? Yes. Please tell what is confusion.
Sir, wait a minute.
Sir, the readings which are already provided in the PPTs and PDFs, do we use those or do we use the readings from the videos?
Yes, it is already given in PDF or PPT. That maybe that's not very differ. Okay, it means I have to check that reading. What is basically it should be not more than one. Okay, so if it is there, then I will tell you or I will correct. I will share with you. Okay,
Sir, in the video that you are showing for the sum experiment, it is mentioned that expected values and the calculated values. But in the PPT, there are only the calculated values. So
yes.
is it to write the expected value also? That's the confusion, sir.
Yes. Expected value you have to write. Whatever it is you are getting from the experiment, you write that thing. Okay, don't worry.
Sir, but how to write the
Sir, what
expected
to write
value?
in discussion?
Don't write expected. Whatever you are actually doing in the you are not doing. You are doing through the online mode. We are playing that you have to write. Okay.
Sir, what to write in discussion means the theory part.
No, what you are observing. It means some parameter calculation you are writing. so that it is given, and based on the different parameters you are calculating the R naught, X naught, that based on that what you understood. Okay, after performing this experiment you have to write that thing.
Okay.
Okay, TK sir, now you
So
continue.
should we have the
Yeah.
questions?
Anything?
Sir, should we have to do questions that's present in PPT?
Yes, you have to
I mean in
include
PDF there is a
questions.
question.
TK sir, they have to include questions also.
Yeah, they can include.
Okay. Anything you want to tell? Otherwise, we will play next video.
Sir, will we have a live Viva at the end of this semester or any exam for this
And that
laboratory?
will inform you later after completing the lab.
Sir, in the
And
end,
Okay, sir.
can you
we
please
most
explain
probably
how to
have
write the
tried
manual with an example of one experiment, sir? Only one experiment. Please explain how to write and
Yes,
what is
sir.
the
yes,
Yes,
part.
sir.
sir.
Yes.
The format, how to do
I
it.
think Tushar sir and
Yes,
Rajesh
sir.
sir already prepared guideline and they have shared. So
Yeah,
Tushar
yeah,
sir, you tell about the guideline and instructions, whatever you have given and shared with all students, I think.
Okay, so let us finish the lab. After that, we can discuss it.
At last, sir will show you or sir will tell you detail. Okay. So should I play another video first?
Yeah, yeah, please.
Okay. Okay.
Or I just will take 5 minutes.
Yes, sir. Should I?
Yeah,
Should
yeah,
I start?
just I will share the screen. I will discuss little bit
Okay.
one or two slides.
Okay. Okay. Please. Yes. Yes.
Okay. Yeah. So we have already gone through the open circuit test of the transformer. So now we will discuss about the short circuit test of the transformer. So for short circuit transformer, as we understood that the secondary side will be shorted, and during that short circuit condition, the current will be very high. The current will be very high because the winding where some voltage will be there, that voltage will drive a huge amount of current due to the very less impedance path of this shorted wire. So there is ideally zero resistance. And if some voltage, if the 5 volt is also there and the resistance is say 0.001 also, then 5 divided by 0.001, that much amount of current, so 500 ampere will flow through that. So that's why we cannot generate very high voltage here, or at least it is must not be making this transformer in such a condition that this voltage will be the full voltage of this rated winding. Means whatever voltage for which this transformer is designed, that voltage will not be there. Otherwise, if suppose this is 55 volt and even 0.1 ohm resistance also is there, so 55 divided by 0.1 means 550 ampere current will flow. So in this way, we should get one idea that this voltage should not be the full voltage of this winding. So this is the key term. So whenever we will go for the short circuit condition, the main purpose of this test is to find the full load copper loss. So how the losses will be estimated? The losses are estimated in case of the transformer test when the transformer is not giving any output power. So if you go back to the other slides, the transformer is kept open here. That means no load is connected. So transformer is not giving any power. So if in this condition transformer is taking some power, definitely that is utilized for its internal losses. So this is the logic. And in the short circuit condition also, it is not sending any power from this transformer to the outside circuit. So definitely if the transformer is taking some power from the wall plug point, definitely that power is also will be utilized for its internal losses. So what type of losses will be there? That is already explained in the theoretical class. First is I'm just repeating that. In case of open circuit condition, as we apply the full load voltage, so definitely the losses which will be performed here, that will be iron loss. And in case of the short circuit condition, as we are performing the test at full load current condition, not the full load voltage condition, full load current condition, so that transformer will consume the power for copper loss, because copper loss depends on the current and iron loss depends on the voltage. So that's why in these two different tests, open circuit and short circuit test, without connecting any load, it is possible to identify the full load iron loss and full load copper loss. So if we make it summed up, so automatically we will get the full load transformer loss, means total iron loss, total copper loss. So that is the main aim of these two experiments, that is open circuit test and short circuit test. So the main purpose of this test is to find the full load copper loss and other parameters, that is the resistance of the equivalent circuit and reactance of the equivalent circuit. At the preliminary stage or primary stage of understanding the electrical technology class, it is very difficult to understand the equivalent circuit of the transformer, and also to understand this equivalent circuit parameter that R equivalent and X equivalent. So this is resistance, R stands for resistance and X stands for the reactance. But still I will try my level best to make it clear that whenever we will have some transformer with us, we can get one equivalent circuit, and that equivalent circuit I will show here, and this equivalent circuit will give some resistance and reactance at the primary winding side, and also resistance and reactance in the secondary winding side. So this X2 and X1 will be appearing due to the leakage reactance of the windings, and these R1 and R2 are the ohmic resistance of the winding, because whenever we will be preparing or making some windings, it will have its own say ohmic resistance, and that resistance cannot be avoided. So we cannot develop the ideal inductor, means without any resistance, it's not possible. So whenever we will take some wire and we will make some windings, primary windings, secondary windings, automatically resistance will be there, as it is are made for electromagnetic induction process, that is in transformers. So definitely there will be leakage resistance, leakage reactance, and there will be some other loops where the losses will be represented. So as I explained in the earlier theoretical class, the resistance is one imaginary resistance which is introduced to show some copper loss. So some losses are happening here, and some other magnetizing components are also there for making the flux. So this is for representing the iron loss, and the loss is considered to be the phenomena of resistance. So that's why resistance is introduced here. So this is about the equivalent circuit, and that equivalent circuit can be approximated further. So in the short circuit condition, secondary winding will be sorted, and there are some theoretical principle by which we can bring this R2 and X2 transfer to the primary side. So as a short circuit condition is conducted at very less amount of voltage, 10 to 15%. So the iron loss loop will be minimized, means will be omitted. Means why iron loss loop is neglected, or it is not included in a circuit, because that iron loss depends on the voltage, and as the transformer is running at very less voltage, so there will be negligible iron loss. So if the iron loss is not there, so we will be removing that part from this circuit, and what will happen, we will get that approximated circuit. So if we delete that, we will transfer these two terms, that is R2 and X2 at the primary side, then we can apply some formula and we can get that R2 dash and X2 dash. And if in series circuit there are two resistances, two inductances or two reactances, then we can also get further approximation, and we will tell that say R1 plus R2 dash will be RE, and J in first bracket X1 plus X2 dash will be XE. So this is the total equivalent reactance, and this RE is total equivalent resistance. So this is the approximated circuit of the short circuit condition, and this voltage is coming from the our supply voltage, or say plug point, wall plug point, or output of the variac. So this voltage is applied voltage, that is called VSC, and this is the current which is entering to the circuit to the transformer, that is called ISC. So these two parameters will be denoted or indicated by our measuring instrument voltmeter and ammeter respectively. So there will be one voltmeter, there will be one ammeter. So those two will read these parameters, as well as we will have some wattmeter connected also, which will read the power, that is the short circuit power consumed by the transformer. So this is about all the circuit calculations what we will learn after seeing the video. So now at this condition, I think you are say well versed with the equivalent circuit of the transformer, which is very important to understand the calculation. So this is all approximated circuit, approximated equivalent circuit of the transformer in the short circuit condition, and that's why we got R equivalent, X equivalent. So now Boris sir, we can play the video.
Yes, sir. So open circuit one also, because they have performed. So in same way.
For okay, so equivalent circuit. Okay. I will do that. So here, in case of the open circuit transformer, we will start from the complete equivalent circuit of the transformer. So we will see that if there is no load, so load will be detached in the open circuit condition. So we will detach the load. Now, if the load is not there, so definitely current will be not there, I2 will not be there. So if current is not flowing through these two windings, so definitely the drops, voltage drops will be 0. And if the voltage drops are not there, so why to bring those things? So we can omit that. So we can just neglect those two parameters. And if the equivalent circuit parameters will be there, so definitely we can bring those things in the this circuit also. So now, as there is a very less amount of current, so the drop across these two will be also neglected. So if those two and these two are neglected, then what will happen? We will have only this branch. So the equivalent circuit branch will be like this. So no current through this and very less current through this. So if the less current through this is there, so definitely this two will be neglected because there is no drop. So this voltage, applied voltage, will be almost similar voltage here. So if the circuit is only connected by one farm wire, then only this voltage will be equal to that voltage. So that's why only equivalent circuit will be the parallel loop, which is called magnetizing loop. So this R0, X0 are already explained in the earlier equivalent circuit class, whatever we have just completed now 5 minutes back. So R is for representing the losses, because the loss is a phenomena which is associated with resistance in electrical circuit. That's why resistance is there. And this is for some magnetizing phenomena. So we will see that one component of current is coming from this I0. So I0 is entering to the circuit, which is nothing but read by the ammeter in condition of open circuit test, and that is fulfilling two purpose. One is making the flux, that is whenever flux is generated, there will be some inductor. So that's why inductive reactance is represented here, and that is called IM, or magnetizing component, IM. And also core loss component, that is IC. So this is also coming to the R0. So this is about our equivalent circuit for open circuit condition. And now we will see that if we have this voltage, that is a V1 or primary voltage, or you can call it as V0 also, because we are giving the at the open circuit condition. So definitely we can call it, sometimes in some books you will find that V0. So that voltage is nothing but the voltage across these two components connected in parallel. So R0 can be calculated by ammeter voltmeter reading. So we can see that this V1 divided by IC, it is this voltage divided by this one current, voltage across this divided by current through this. So this is R0, and IM will be also used for dividing V1 so that we can get X0. Now how IM and IC can be obtained? So IM is equal to I0 sin phi 0, magnetizing component. IC equal to I0 cos phi 0, that is the active or core loss component. And this phasor diagram can be explained in this figure very nicely. So now we have what we have. We know the open circuit power consumed by the transformer. Voltage is open circuit voltage. I0 is the current at the open circuit condition drawn by the primary. Now W0 equal to nothing but V0 I0 cos phi 0. Cos phi 0 is called no load power factor, and cos phi 0 can be calculated by dividing W0, that is wattmeter reading, divided by V0 I0. And if we have the I0 and if we have the cos phi 0, then we can get IC equal to I0 cos phi 0 and IM equal to I0 sin phi 0. Now how sin phi 0 is calculated? Because cos phi 0 is known from the wattmeter, voltmeter, ammeter reading. Cos phi 0 is known, means sin phi 0 can be obtained. If sin phi 0 and cos phi 0 are known, and if I0 is known, then we can multiply I0 with cos phi 0 to get IC, and I0 with sin phi 0 to get IM. So if IC and IM are known, then we can get R0 equal to V0 by IC, whatever we have studied here, and XM or X0 equal to V0 by IM. Hello?
Sir, one doubt. Sir, one doubt is there.
Tell me.
Yes, sir, in the previous slide, uh,
Mhm.
sir, why there is two losses considered in the primary side? Like one is connected in series and one is connected in parallel, and the on the secondary side only one loss type is considered.
Where?
Like here we are connecting the resistance and the inductor in parallel and resistance and inductor in series for the primary side, but here only two are there. So why it is like this?
Here, because this is the driving coil, it is only making the flux. Okay, this winding is making the flux, and that flux is linking with this winding, and it is only generating the or inducing the voltage. So if that winding is given power here, if some power is given and if some power is drawn from here, this branch will be drawn here. Okay, so this is the phenomena of primary winding, because we are giving the power and this is only generating the flux, and that flux is linking with that, and it is giving some power, or it is getting some capacity of delivering power due to the power given in the primary. So it is a dependent coil, it is independent coil. In this way you can understand.
And sir, the series part that is there in series R1 and X1, and here in secondary the series R2 and X2. So sir,
Because transformer have
represent
two coil. Listen, hers. Because transformer has two coil. Primary coil, it has some resistance and inductance. This is coil, means copper coil. Okay. On the primary side, that you have seen, it maybe you have not studied the transformer. Transformer basically is, as sir also told, that laminated core is there, that rectangular core is there. On one side, primary winding is there, that copper wire is bonded. The copper wire, when you wound that, so it has resistance and reactance both. Okay, it means resistive part and inductive part. Okay, so and it also has on the secondary side, after the transform action, secondary winding also responsible to induct on that after the transform action. Okay, secondary winding also have. When some load you connect or not, that is another issue for the open circuit test or short circuit test. But it has two windings. Okay, each winding has some resistance and reactance. Okay, that's why R1 represents for primary winding resistance reactance. R2, that after you see iron core representation by the parallel line, it is shown in the secondary side, R2 and X2. I think you have not learned that transformer theory. That's why you are asking this type of, but it is fine at this stage. When you will learn transformer theory, then it will be more clear. And R2 and JX2 representing the secondary winding resistance and reactance. Okay, and that here you can ask again, maybe sir, that beside that RC1 or LM, why they are representing IC or IW or IM, why it is that sir told that one component, that core component, core loss component, okay, at the no load condition, or that another component, magnetizing component, which is responsible for the electromagnetic induction, okay, to transfer the magnetic energy. Understood? This is basically concept here.
Thank you, sir.
Am I right,
Thank you, sir.
TKV sir?
Yeah. And the thing is that you see that this R1 X1, they are connected in series because they are conducting same current, because this is the property of copper coil. Okay, copper wire. This is also same. It is also property of copper wire. So it is also conducting the same current. That's why they are in series. But here voltage are same, because those two currents are divided for two purposes. In which circuit currents are divided? Definitely in parallel circuit. So that's why in this logic it is made, because it is utilized or representing some loss, and that is related to iron. So that's why it is the equivalent nature of the iron, property of iron. So some power will be lost, but some magnetization will be there. How the magnetic field is developed? That magnetic field is developed, that is the magnetic material as well as current is there. So current, whatever is there, that is entering to this circuit by this nature, say total I0 or so whatever is coming here. So that type of current is coming through the winding, but still it is interacting with the entire electromagnetic circuit and it is generating the flux. So that's why, as the flux depends on the voltage, so definitely it will be connected in this way. So whenever it will be taught during the say transformers chapter, definitely it will be again explained in detail. So some confusion may be there because you have not studied the transformer yet. But
yes, so
still
we can go for next video, sir.
Next, video, yes.
And for open circuit test, we have to check readings again and calculate. So if it is some mistake while we have taken reading, so we will verify, then we will share with you readings. Okay. For open procedure will be same, everything will be same. Okay. So we will verify readings again. Okay.
Okay.
Sir, so should I start, sir?
Yes. So any more doubt, students?
Sir, how to relate figure 1 and figure 2 in this slide?
Where?
Previous
This
slide
one?
you have shown,
This
no?
one?
Equivalent circuit slide.
Here. Okay. This I0 is the no load current, whatever is flowing through this.
No, sir, I am asking about equivalent circuit.
Equivalent circuit.
Previous slide.
Here.
Previous.
Okay.
Figure 1 and figure 2.
Okay. Yeah, yes. Figure 1. Yes, I am telling. So Ashish, you will tell or I will explain?
Yes. What is your doubt here?
Sir, how to relate figure 1 and figure 2?
Oh, figure 1 and figure 2. You see. Nothing. This is just open circuit. You see, you have not connected secondary side anything. It means this is open circuit 1. And what basically you have done? I want to refer these things and relate the things in terms of referred things. Okay. It is written that equivalent circuit referred to primary. Okay. And you have not connected secondary side anything. And what you have done basically, the equivalent resistance R2 is there in the secondary side, but when it will come primary side, it is not R2. That is turn ratio will come in picture. Okay, so when it will transfer to primary side, it will be R2 dash. Okay, and it's now again in the secondary side it was in series. So when it will come in a primary, it will again in series or that parallel, whatever arrangement it is here. You see that it is first part RP, it means RP and XP for the primary, and RS and XS for secondary referred to primary. Secondary parameter, it means secondary resistance and secondary reactance, which is referred to the primary in terms of turn ratio. Turn ratio is what? NP upon NS. Okay, this is basically transform turn ratio. Okay, it means how many number of turns in primary and secondary winding. Based on that, its resistance and reactance when it is referred to primary, or the primary resistance and reactance referred to the secondary will change. Okay, so this is basically referred circuit to the primary. Okay, secondary resistance and reactance. Yes.
Yeah, this is actually approximation procedure. So the same thing can be made. That means R1 and JX1 can be transferred to the secondary also. So at that time, this branch will come here, and it will be also called as say R1 dash and X1 dash, and that will be also will be associated with the ratio. But at that time, it will not be NP by NS, it will be NS by NP. That you should remember.
It will change according to the turn ratio.
Yeah.
When you will refer in a primary or in secondary.
Yeah, just for clue or trick that how to remember, you just think that whenever referred to what side, referred to primary side, at that time primary parameter or primary turns number will be at the numerator side. Okay, you see that NP is above, NS is down. So whenever it will be referred to the secondary, so that's why the NS or the suffix will be at the numerator side, means it will be at the above, NS by NP.
Now, sir, you stop sharing. So should I continue?
Yeah,
okay,
please.
no.
Thank you.
It is clear to. Yeah. Thanks.
Is it visible, sir?
Yeah. Ashish, the introductory slide is there, I guess, that you can skip that our laboratory
Yes.
introduction.
Yes, I have skipped this.
Yeah, little bit.
Yes. So now a short circuit test. Okay.
Yes.
Just wait. I will share again.
Good evening, all. So we are again in the laboratory of
Is it audible,
electrical
sir?
technology, and today we will discuss about
sir.
the short circuit test on the single phase transformer. So here you can see the panel board, and that panel board is suitable for understanding the connections. And near the panel board, the experimental table is there. We can see all the experimental components or instruments are connected already. We will be discussing that, how it has been connected. And lab manual is there, so you will go through the lab manual and circuit diagram. So now we will do the short circuit test of the transformer. So we will follow the short circuit test circuit diagram. As the circuit diagram shows, we need to connect the transformer as shown in this figure, and all the components are shown here. So what type of instruments are required? First of all, we will see the transformer. Same transformer will be used, what has been used during our open circuit test discussed earlier. And the rating of the transformer is 1 kVA transformer, power rating, and 220 volt / 55 volt. So here we also see from the panel that 220 volt is the high voltage side and 55 volt is the low voltage side. Now, as a thumb rule, we will sort the low voltage side. That means we will apply the power to the high voltage side, that is 220 volt side. So that power will be consumed as the full load copper loss of the transformer in this short circuit test. So short circuit test, as it has been already explained in the theoretical discussion classes, that is conducted to estimate the full load copper loss. So there are two windings, so there will be two losses, primary copper loss and secondary copper loss, and the wattmeter which will be used in this experiment will give the reading of the total copper loss, that is primary copper loss plus secondary copper loss. Here primary winding will be high voltage side winding. We will choose that winding as the primary winding because we are going to give the power from the variac or thermostat. We will be giving the power, and that's why this winding 220 volt side winding will be called as the primary winding, and 55 volt winding will be called as secondary winding. So as for the short circuit test, secondary winding will be sorted directly by any wire, or we will be sorting with an ammeter, because ammeter has also very less resistance. So if we connect ammeter as shown in this figure, so we will consider that winding has been sorted. Okay, so now we will be discussing about the component or instrument. First of all, the 220 volt variac will be there. So we will get maximum 220 volt, or even we can go for the more depending on the manufacturer specifications. After that, we will use one ammeter to read the input current which will be consumed by the primary winding, that is 220 volt side winding. And after that, the wattmeter will be connected. Here you can see that M, L, CV points, which are very well known to all this time after discussing several times during the theoretical classes. So M and L will be the current coil, and MCV that will be showing the pressure coil or voltage coil. So
M stands for say main and L stands for line, C for common and V for voltage. And after that, we will see that there is one voltmeter which is connected in parallel, as the voltmeters are connected always in parallel. So that voltmeter will be measuring the primary
voltmeter reading is wrong.
voltage we are giving. So we will be changing the voltage in the
Yes. This is 300. Okay, so don't worry. So this is a type of mistake. Don't worry. Okay, if it is 220, so it is 300. Okay.
No. Actually, we are applying very less voltage. So this 220 is full rated. So we are not going to apply any full rated voltage. Fine. So very less voltage will be applied in that case. Otherwise, there will be huge current. So that's why we will apply very less voltage, and that will be say 10 to 15% of the rated value. Means
Yes.
220 volt is the rated value of this winding. And if we suppose we consider 10% is enough to send the full load current through the other winding, secondary winding, so it will be 22 volt, and that voltage is coming under the range of this 0 to 50. So this voltmeter is for this condition test, it is fine.
Okay.
Yes. Because you perform the short circuit test on the rated current, not rated voltage. Am I audible? Yes.
Yes, sir.
Okay. So, sir, should I continue?
Yeah, please.
variac side. We will be reading that voltage continuously at the voltmeter that is shown here. 0 to 50 volt range is a very suitable one. But any voltmeter is possible to be connected. But here we will see that the voltage required for this experimentation will be 5 to 15% of the full load voltage. That is 5 to 15% of the 220 volt side. Means 220 voltage is the rated voltage. So 5 to 15% of the 220 volt will be the required voltage, minimum required voltage to send the full load current through the secondary, that is in the 55 volt side. So how to get the reading of the secondary voltage, secondary winding? Because we have already connected the emitter, so we will get the emitter reading and we will get the current. And as for the transformer specification, that short circuit current can be calculated from the kVA rating. So kVA rating is 1 kilovolt ampere. So definitely 1 kilovolt ampere should be divided by 55, because that side, secondary side, is the 55 voltage side. So automatically we will get 18.18 or 18.2 ampere. So that type of ampere current is called as the full load secondary current. Now we will be discussing about the real experimental setup, that how all the instruments are connected. So first of all, we will start from the main supply board, which is installed on the wall of our laboratory. There will be one 3-pin plug and switch, which will control the main supply. That is switching on and off, will give some power and disconnect the power. After that, thermostat will be there, and thermostat will be rated with the scale. But due to several usage or due to some manufacturing mismatch with the rotating knob and the scale, we cannot tell that exactly whatever is shown on the scale will be going to the input side. So that's why we will be using some voltmeter. Here we will be using the panel meter, digital voltmeter or digital panel meter, which is shown here. So here you can see these two wires are coming, and these two wires are connected across this 220 volt side winding. So it will be measuring the voltage coming from this thermostat. So you will get an idea from this scale, but exact value will be displayed by this panel meter. Okay, after that we will get the emitter connection. So we will start from the positive terminal of the variac, that is this one is considered, though we can consider this also, but here we have considered this one as positive. So we will keep in mind, and red wire is going to the input of the emitter, and that input of the emitter will be connected to the common point. And after that, the emitter will be connected to the 5 ampere range, because the full load primary current, so we have connected the 5 ampere range, full load primary current will be 4.5 approximately. So it will be also calculated by dividing 1000, that is 1 kVA divided by 220, because we are going to measure the current through this primary winding, which is high voltage winding. So 220 volt side winding, and power, total power is 1 kVA divided by, so it will be 4.8 will be suitable range. So we can see that 4.8 range is there. So let's see how much current is coming, because if we connect to a 2 ampere or 1 ampere range ammeter, then it will not be suitable for reading that, because the expected value or measurement will be little higher than that. So it is better to connect with any ammeter greater than 5 or at least 5. So we have connected to a 5 ampere, 0 to 5 ampere ammeter. Okay, so after that ammeter connection, the ammeter is going to the point M, we can see. So we will also see that the ammeter wire is coming, and this wire I will show you clearly. So this is the ammeter. So this is the ammeter wire is coming, and it is going to the point M. So this is the point M. And after that, that M is the current coil starting point. So ending point is the L, and that L will be going to the L will be going to the primary winding or 220 volt side winding, and that end point will be going back to the voltmeter point. So that it is displayed here in the circuit diagram. And now point to be noted that M and C points are not connected directly. M and C points are not connected directly for the wattmeter, so we need to sort it out. So that's why we have connected the C, means common point of the wattmeter. C is connected by one wire. So this wire is taken as a longer. We can use the short wire also. That is also possible. So M and C are sorted. And after that, the wattmeter negative point or the voltage terminal, which is connected here with this is the 150 range. We can see if we make it straight. So I think the 150 is not clearly visible due to the wire connections. Now it is visible, I think. Or yes, it is 150 volt connection is there. So green wire is connected to 150, and that 150 voltage or volt point is going to the returning path of the variac. So in this way, the circuit diagram is completed. And in the secondary side, that is in the low voltage side, that is 50 volt side, 55 volt side, we will connect one ammeter as we have told. So one point from the positive terminal of the 55 volt is coming to the 30 ampere range, and the negative point of that point of the secondary coil is coming to the common point. So we can see here in the common point it's connected. So secondary side is also connected by one ammeter, and that ammeter is used to measure the secondary short circuit current as well as to make the secondary shorted, because ammeter has very less resistance, so definitely it will work as a short circuiting element. And that current will be 18.18 or 18.2 approximately current ampere will be flowing at the condition when the 5 to 15% voltage of the primary is applied. Why that 5 to 15% voltage is sufficient to send the full load current through here? Because whenever there will be lamps, there will be loads. But in the short circuit conditions, the lamps will not be there, no load will be connected, so only one small wire will be there, which is very less resistance. So very less amount of induced voltage here will be sufficient to send at least full load current 18.18. Now for inducing that small amount of voltage, primary voltage also will be required very small, not the full is required. So that's why 5 to 15% of the 220 volt, that is of that winding rated value, is required to send the full load current through the secondary one. Here you can see that as the current value is high, that is 18.18 ampere, so definitely we will be seeing we have connected to a higher range, that is at the range of 30, means we will be connecting to the 30 ampere range, so that it comes under this measurement value. There are other scale is also there 15, but as the 18 is more than 15, so we will not choose that 15, otherwise we will not be able to measure the full scale deflection. Okay, so now we are going to switch on the powers. So those two plugs are the power to the thermostat as well as power to the panel board, so that we can utilize the digital panel meters, because digital panel meters need some power. Okay, so now we will increase the power or increase the voltage by rotating the knob of the thermostat. We will gradually increase and we will see how the meters, that is ammeter, voltmeters, are showing. So right now the voltage applied to the input increasing gradually, and you can see that the power is being consumed by the transformer, so power is increasing. And ammeter, the input current to the primary winding also is being measured. It is connected to the 5 ampere range, so upper scale will be considered. And in case of the secondary winding also, we are seeing that high value of current is going. So now it has reached to the 18 ampere, so it is approximately the full load current. And for that full load current, the required primary voltage is 18 volt, so which is the very less value compared to the full rated value of the primary winding, that is 220 volt winding. So 18 is very less, 18 or 17. So it comes under the range whatever is mentioned in the manual. So now we will note down all the powers, amperes and secondary amperes readings, and also we will take the voltmeter reading of the primary winding, so that we can calculate all the circuit parameters as explained in the manual. So here we can see the primary voltage, so we will note down as 17 volt. Primary current, that is ISC or I short circuit, so that will be found from this ammeter, which is connected to the 5 ampere range. So we will take the upper scale. It is 4.4 and then it is 4.45. It is coming approximately 4.5, but we will write 4.45. Okay. And after that, wattmeter reading. Wattmeter reading will be collected from this wattmeter, which is a little bit fluctuating. So now for wattmeter reading, we need to check the multiplying factor for wattmeter. And for checking the multiplying factor, we need to know at what ampere range and at what voltage range wattmeter has been connected. So here you can see that B1, E2 is sorted and B2, E1 are sorted. These knobs are for controlling the current capacity of the wattmeter. And depending on the connection which is mentioned in the nameplate of the wattmeter, we can see this connection, that is B1, E2 and B2, E1, when these are sorted, it is for the 2 ampere range. Here we can see that. And also we have already explained or mentioned that wattmeter voltage rating is connected to the 150 range. Here we can see. And for that also we can get the voltage rating. So we will see that for 2 ampere and 150 volt, the multiplying factor is 2. So whatever reading will be obtained here, the value, that wattage is required to be multiplied with 2, so that we can get the actual power consumed by the transformer at the short circuit condition. So we will write the value, that is 52 multiplied by 2. So wattmeter multiplying factor is 2. That's why reading 52 multiplied by 2. This is the total consumed power. And using those values, we will calculate all the circuit parameters as it is mentioned in the manual here. So please note the short circuit test calculation. That is, we need to calculate the RSC and we need to calculate the ZSC and XSC. So RSC, XSC and ZSC all are the equivalent circuit parameter, which has been explained in the discussion classes. And we need to take the values of wattmeter and ammeter and voltmeter, so that we can get the values of RSC. As it is shown, the RSC will be calculated by dividing the wattmeter reading by the square of the short circuit current, and ZSC will be obtained by dividing the voltmeter reading, that is VSC, by the short circuit current value, that is ISC. And whenever you will have the ZSC and RSC, we can calculate the XSC, that is the reactance part, equivalent reactance of the transformer at this condition. So it will be root over ZSC square minus RSC square. So root over line will be equal to be more, yes. So it will be a little bit more here, yes. And after that, we need to calculate the efficiency of the transformer whenever the primary copper loss and secondary copper loss is already known, and also the transformer iron loss is known. So we can get the idea about the entire loss. So in the formula, you can see the efficiency is calculated by the standard formula, that is output by input. So output power is already mentioned here, and the copper loss and iron loss is added to the output power, and we can calculate the efficiency. So
Sir, here
from the open circuit
WCU
test,
is copper loss.
Wi, that is iron loss, is obtained as the wattmeter reading at that condition, that is open circuit condition. And for copper loss, it is the wattmeter reading in the short circuit condition of the transformer. Thank you.
Hello.
Yes, sir. Yes, sir.
Hello.
Yes, sir. Yes, sir. You continue, sir.
Yeah, students, anybody has any doubt? WCU is copper loss, WI is iron loss.
The calculation part of this experiment is not clear. Where we
What?
will get the resistance?
Resistance you will get by dividing the voltmeter reading by the ammeter reading. Okay, so I will go to the slide for calculating the parameters. So I will share my slides. Is the slide visible?
Yes, sir.
Yes.
Yes, sir.
Okay, so you just
VSC means short circuit voltage, sir.
Yeah, VSC means short circuit voltage applied to the primary winding. Fine. Whatever voltage was there, we noted now that is 17 volt, approximately 17 or 18 volt.
Yes, sir.
Okay, so that voltage is nothing but VSC. Means why it is called VSC? It means the voltage during short circuit condition. SC is short circuit. SC stands for short circuit. ISC means current entering to the circuit of the transformer during short circuit test. And these are the other two parameters, that is RE or RXC, or in the video or in manual something is shown that RSC or XSC, all are same. Okay, so you have to think about the equivalent resistance and equivalent reactance. So now if this is a voltmeter and this is the ammeter reading, then there will be wattmeter power also. So this relation can be easily found, that power is nothing but R multiplied by I square. Okay, so current entering square into resistance. So that much power will be consumed. So this is wattmeter reading. If you divide it by the square of ammeter reading, we will get RE. And if we have voltmeter reading and if we have current or ammeter reading, we can divide those things. So we can divide voltage obtained in the short circuit test dividing by the current obtained in the short circuit test. So those two parameters will be known because we already connected here in the circuit. We have seen there, you can see that current reading is there, voltage reading is
sir,
there.
I got.
Now got it? Okay, so this is actually
Yes, sir.
VSC. You see that VSC, and this is current entering ISC, and this is WSC. Now if you divide this wattmeter divided by the current square, you will get the resistance. If you divide this voltmeter reading by current, you will get that resistance also. So by this you can get this formula here. So you will get the total resistance, mean total impedance, and you will get the resistive component or loss component. So you will get RSC or R equivalent by wattmeter reading and ammeter reading. You will get the Z or impedance by the voltmeter and ammeter reading here.
Okay.
Okay, so here if you have this voltmeter and if we have ammeter, then if we divided this VSC divided by ISC, then we will get total impedance, means by which impedance this winding is trying to oppose the current. Simple series
So sir,
circuit.
ISC is the value of primary current.
Yes, because
Okay.
I already explained that all the parameters has been shifted to the primary. All the parameters, that's why have been shifted to the primary. That's why those things are all equivalent resistance or equivalent reactance, whatever is obtained for the approximation made with referred to the primary winding. So that is already done. That's why we are getting these parameters. So that's why these are all primary winding side current and voltage. This is primary voltage and this is primary current, and power is primary winding the and whatever is there in the secondary, that is also because transformer is transferring some power to the induction also, na? So whatever current is entering here, due to that current only some flux is generated, and due to that flux voltage is generated here, and due to that voltage some current is flowing. So whatever power is available or is consumed in this winding also, that is the part of the entire power, because somewhere else power is not entering, through the primary winding only it is entering. So whatever power is entering, that is total power loss, means primary copper loss and secondary copper loss, because in secondary how the power is coming, it is not coming by magic, it is coming from the part of the primary only. And for calculation we have all referred to the, all parameters have been referred to the primary side. That's why we are using, or we are able to use all the primary readings, primary winding readings. Okay, so we are getting this voltage at the short circuit condition, and we are getting current at the short circuit condition. Now if the impedance of this winding, that is R plus jx, R plus jx means these two, R plus jx. So this is total impedance, na? So R square plus x square, it is whole root over, that will be only the impedance amplitude. So that's why
Yes,
we are
sir.
considering the voltage drop, total voltage. This voltage will be dropping across this, na? So across what? One R and X is there, one inductor is there, one
Under
R is
VR
there. So
square plus VX square.
yeah, so this is a series RL circuit. If the series RL circuit is there, what will be the impedance? And that impedance is nothing but, even that can be approximated by Z. That's why it is called ZSC. So this is also approximated by 1 Z. This resistor and inductor combination, series combination, is possible to be replaced by one impedance, and that impedance is nothing but this ZE or ZSC. Okay, and this is nothing but RE plus JXE, or amplitude wise we can calculate that. So ZE equal to R square plus X square root, whole root. So if we have ZE and RE, then we can calculate XE very nicely from Z square minus R square whole root over. So that is done only. So now I think the calculation part is clear to you. Any other doubt?
No, sir.
Okay,
No,
okay.
sir.
So if you have any kind of doubt, anything regarding this experimentation, keep posting me in the WhatsApp, or keep sending me some emails, or you call me. Okay, so if any, because this transformer test is being conducted say for you when you are not aware about the transformer uh, from the theory classes, because it is not yet covered, na? So it will be very difficult. That's why I am repeating again and again, so that it will be also helpful for whenever you will read the transformers chapter or transformer section. It will be very useful for you. It will be easy to understand because it is already explained. So but at this time it will be a little bit difficult, but still we are trying by our best so that you can get the concept of the test. So I think there are no such other doubts. If there is no such other doubts, then we can log it out. Or if anybody from you have any kind of doubt, you can ask me.
Sir, we ask
Sir,
for
how
an
to
example
KV
of.
rating is always one.
One by one,
Yes,
please.
sir.
One by one.
Example, sir.
One by one,
Yes, sir.
please. One by one.
Example,
Sir,
take one experiment as an example and show how to write the manual for this lab.
So you want one example?
Yes, sir.
Yes,
Okay,
sir.
so
yes, sir.
for that, I can give you some text. Okay, I can write. Say I will type it, but you should, as per the instruction, you should write in your handwriting. Fine. So, but whatever I am going to send, that will be typed. So I will type something little bit about the say transformer, about the connections, about the readings. All these things will be given little bit, not fully. So after following those things, you can write. That I can do it for you.
Sir, one
That
thing
Okay,
I
will
sir.
want.
be handwritten.
Yeah, your thing from your side, it will be submitted after handwriting, and whatever I am going to send, that will not be full also. Mind that. I will be writing 2-3 lines for each section, and I will mention how to write. Fine.
Yes, sir.
So, what is the deadline for us?
Deadline, I will let you know. Definitely it will be after 1 week of from the date of completion of all the labs. So if that say completion of the lab is done by say 15th of March, for example, fine. So 21st March will be your submission time. But now if you start writing after completion of all the labs, then it will be a big burden for you. So our suggestion is that whatever lab is completed or being completed, you start writing those things so that your work will be divided and you will be also in a good position.
And sir, we have
You
to just
follow?
put one set of data, sir.
Yeah. For transformer test, you have to take only one set of data.
Okay, sir. Thank you, sir.
Okay.
Okay. And reading, we will
So,
verify.
how do we get KVA rating?
KVA rating will be 1 KVA. So I will also send you the data set as a Word file. Fine.
Yes, sir, for all the experiments, sir.
For all the experiment, I cannot send. So I will send from the for the transformer experiment, I will send the data to you. It will
Yes,
be
after verifying.
yeah.
For
It will be
other
posted.
experiment,
It will be
mail.
no. I will send through both. I will be sending always. I am sending to the mails again. I am sending or I am posting it to the WhatsApp groups. So anybody from you are there who are not in the WhatsApp group?
Sir, me. Nikhil
So
Kumar.
why you have not contacted me through your
Sir.
CR or anybody else? Because I already made 2 groups. I can make another 2 groups also. Because
Sir,
yeah.
Sir, we will
the
upload.
group
We will
was
upload
full.
an MS Team also here.
Yeah,
But
Yes, sir. MS Team, sir.
yes, we
definitely
will
it will be there.
upload here also.
I have
Yeah.
contacted CR, but they don't tell me.
So you don't have my number or
No, sir.
Asis's number.
No, sir, I don't have.
You take the number from the website. You didn't get any email from me.
I'm not getting the email also. Sir, number I can take from the website, sir. Yes.
So Nikhil, I think you have contacted me today. No, or not Nikhil, somebody else. Anyway, you take the number from other friends also. You can contact me. You can send your emails.
Sir.
Yeah.
Sir,
Yeah, you
please
send.
confirm about that expected values and the calculated values, which both we have to write, or the calculated value will be enough.
Which one?
Here you have to write. Yes. Just listen. Here you have to write whatever reading. If some correction is there, we will update you regarding the transformer, and whatever we are getting from the experiment, that you have to write in observation table. Okay. And after that, you have to do calculations. Okay, based on the recorded parameter. Okay, via the different meters.
So
And
short circuit test data and open circuit test data will be sent to you. Okay, it will be uploaded in the MS Team.
Okay, sir.
Okay, so you do all the calculation with that. So I myself and Ashish sir both will upload the short circuit data and open circuit data.
yes.
Okay.
It is okay here.
Okay, sir.
Okay, so
Okay.
it will be done. It will be done by tomorrow So after tomorrow, you can start writing your manual because data will be ready. So you have to take the data and you can use the data for calculating the short circuit parameters and open circuit parameters.
Here it is possibility when we do recording, maybe parallelly we have not taken reading properly. That maybe it happened. So we will check all the readings and we will share that thing also. Okay.
Okay, sir.
So
Sir,
okay.
sir,
Yes.
sir, in other experiments also there are suppose only one readings. So is it we'll write only one reading or we'll have to
No.
take other readings?
You have to ask respective instructor in which way they are continuing. Is it fine, TKV sir?
Okay, okay. For them actually contacting the faculties may not be always possible. So I will send one thing. I will do one thing. I will communicate all the instructors and I will request them to upload a say Word file for each experiment for their or corresponding experiments, that just data set so that they can use. Now, if any faculty tells that whatever is shown in the video is final, that actually should take to the student. So if anybody wants to send the data with a fresh Word file, they will be invited and they will be requested. So I will send the email to all the faculty members, and if you find any Word file in the corresponding folder, then you take that as a final data. But if you don't find any data, then you have to take the data from the videos. Is it clear?
Okay.
Yes, sir. Okay, sir.
Okay. So I will
Yes, sir.
request the faculty members, all the sets, that send or upload one Word file with complete data set or final data set, so that can be useful for the students' calculation and manual writing. And after that, if you don't find any Word file as a data, then you have to take that data from the video or whatever is explained by the concerned faculty member. Okay, but for the transformer experiment, myself and Boris sir are confirming you that by tomorrow data file will be there separately. You have to take data set from there.
Yes, for open circuit and short circuit test.
Yes, both the data set will be there.
Okay.
So also, so one more thing.
Yeah.
So the whole of the experiment